Hi everyone, my name is Shokmarapam. My teammate Kanandra Okramsetti. We together did a 2.5 giga sample per second, 8-bit time interleaved SAR ADC under the project advisor Hamediha. And in this 2.5 giga sample per second, 8-bit time interleaved SAR ADC, we utilized a 45 nanometer CMOS technology, which ADCs comprise of 64 single core ADCs and which harness the capabilities of time interleaved unlocked to digital converters. And these time interleaved SAR ADCs are mostly used in high-speed wireless communication, such as a PAM4 or backplane receivers or fiber-optical receivers, and to the high sampling rates by operating the multiple ADCs in parallel. So this is our structure, and we in this time interval SAR ADCs we did entirely build the clock generator circuit using the DA local loops or D flip-flops. So first we tested using the idle clock generators, then we tried with the D flip-flops, then we tried with the DA local loop. So our main intention is implementing the time interleaved SAR ADCs using the DA local loop. And so each in our first we implemented the DA local loop operating at the 40 megahertz, which can meet the demanding specifications of the 2.5 gigahertz sample per second by having the 64 stage in inverter based voltage control delay line to produce the 64 even distributed phase signals. So these signals are crucial for the synchronization operation of the samples and hold stages, ensuring the low jitter and high precision in the timing of the analog signal capture. So first I want to explain the core ADC structure, which is a main building block of the time interval SAR ADC. So in this core ADC structures we have a sample and hold blocks, then capacitor array, then comparator and clock generator and SAR control block and the feedback loop. So entire we did under the 45 nanometer technology, and we will capture the signal, and correspondingly we have a comparator, and the comparator compares between the two signals, and these two signals after doing comparison this comparison will be done in 8 clock pulses, like for one complete comparison we have to have the 8-bit output. So this core ADCs will have run at 40 megahertz and providing like a 8-bit output. So and we did entire thing under the run under the 1 volt power supply, and we implemented this core ADCs in block level structures that are having a sub ADCs. Each sub ADC is having 8 core ADCs. So we have a one sub ADCs having 8 core ADCs. We have 8 in parallel, same core 8 sub ADCs. So for that we need to have a proper clock and proper signal, and we have to get a proper output. So first we implemented using the idle clock generator, then we implemented using the D flip-flops, and then we implemented using the DLLs. For the clock generation we used 3 different techniques. So and ultimately we have to achieve the DLL based time interleaved SAR ADCs. So this is our sub ADC structure, and this is our DLL locked loop structure. And in a DLL locked loop we have like a PFD circuit and charge pump and the voltage control oscillator and bass circuits, and even the power supply we generate on our using the band gap and LDOs and bass circuits. So we for the entire requirement of time interval SAR ADCs, the clock generator circuits and power supply units and core ADCs and the time interval structure and everything we have in the same chip. So it's a self-sufficient chip, and this is results of the DLL multiplex clock generator, and this is timing diagram of the single core ADCs, and this is overall output of the time interval SAR ADCs. And this is the FFT spectrum. This is like after the DAC, the FFT spectrum of the single core ADCs. And in the conclusion part, and we built the most of all the circuits like Preamplifier, Strongarm Latch, clock general circuit, and Bootstrapped switches for the core ADCs, and we did the Monte Carlo simulations and comparison offset, to check the comparison offset and everything. So we found like a proper ENOB, SNR, and SFDR, and we had simulation of the Cadence simulation, transient simulation, and everything. So at the end we got the perfect output, as you can see at the in the diagram. So where we had like a proper output signal after the tag. So this is like a total time interleaved SAR ADC structure that we've implemented on 45 nanometer CMOS technology, Cadence GPDK. Thank you all. Yeah.